AI systems are becoming a critical part of everyday business decisions. But unlike traditional software, AI doesn't simply work or fail. Its performance can gradually change as data, users, and real-world conditions change. That's why AI observability matters. In this episode of Everything You Need to Know About AI, we'll look at how organizations can continuously monitor AI across 4 critical dimensions: data, models, infrastructure, and business performance. The goal is simple: monitor what matters, detect problems early, and govern AI with confidence. Why do we need AI observability? First, AI systems can degrade silently. A model may continue producing predictions, even as those predictions become less accurate. There may be no crash and no obvious error message. Second is compliance and trust. Organizations increasingly need the ability to explain, trace, and audit AI decisions. And third is ROI accountability. Leadership needs more than model accuracy numbers. They need evidence that AI is actually improving revenue, productivity, costs, or operational performance. Think about it this way: we wouldn't operate a critical production database without monitoring. AI requires that same level of visibility, and often even more. A strong AI observability strategy covers 4 dimensions. Number 1, data, monitoring freshness, completeness, and quality. Number 2, model, tracking accuracy, drift, and bias. Number 3, infrastructure, monitoring GPU utilization, latency, and throughput. And number 4, business, measuring ROI, user adoption, and operational impact. Together, these 4 dimensions provide a 360-degree view of how an AI system is performing, technically, operationally, and financially. Let's start with data monitoring. Data freshness tells us whether the information feeding the model is current. Completeness identifies missing fields or broken data pipelines. And quality monitoring looks for statistical anomalies, schema problems, outliers, and unexpected changes in distributions. Then comes model monitoring. Accuracy can be measured through metrics such as precision, recall, and F1 score, with thresholds established to trigger alerts when performance declines. We also need to monitor drift. Data drift occurs when the distribution of model inputs changes, while concept drift occurs when the relationship between those inputs and the expected outcome changes. Finally, there's bias. Organizations should monitor fairness metrics across relevant demographic segments to identify unexplained disparities and support regulatory requirements. The key is detecting these changes before they translate into bad business decisions. Now let's look at the infrastructure running AI. Start with GPU utilization. Imagine a 40 GPU cluster operating at only 30% utilization. That represents significant unused capacity and unnecessary cost. But running continuously at 100% utilization isn't ideal either, because there's no headroom for demand spikes. For many environments, a practical target described here is around 70 to 85% sustained utilization. Next is latency. For interactive AI applications, response times above approximately 300 milliseconds can start to feel sluggish. That's why teams should track not only average latency, but P50, P95, and P99 latency. Throughput, the number of requests processed per second, provides another important scaling signal. But technical performance is only half the story. Business monitoring measures ROI, adoption, and operational impact. Establish a pre-AI baseline and compare improvements in revenue, costs, productivity, or efficiency against the total cost of running the AI system. Also track daily active users, feature engagement, and how often people override AI recommendations. A technically excellent model provides little value if people don't actually trust or use it. So how does everything work together? Think of AI observability as a continuous 4-step loop. Collect, detect, diagnose, act. First, collect logs, metrics, and events from data pipelines, model servers, infrastructure, and applications. Second, detect anomalies, model drift and threshold breaches. Third, diagnose the root cause. Is it a data issue, model degradation, infrastructure capacity, or is it affecting the business? And finally, act, retrain the model, roll it back, scale infrastructure, reroute traffic, quarantine problematic data, or escalate the decision to a human. One of the most important numbers in this presentation is the cost of implementing observability early. Building observability into a new AI system is estimated here at approximately 5 to 10% of total project cost. but retrofitting monitoring after the system is already in production can potentially cost as much as rebuilding the system. That makes observability something to design from day one, not something to add after something goes wrong. AI observability ultimately comes down to one question: can you trust what your AI is doing in production? Effective monitoring needs to cover all four dimensions: data, models, infrastructure, and business outcomes, while continuously moving through the collect, detect, diagnose, and act cycle. Start by identifying your highest-risk AI systems, understanding where your monitoring blind spots exist, and defining alert thresholds and escalation processes before an incident happens. At Cresco International, we help organizations design and implement AI observability frameworks built for scalable, trustworthy, and high-performing AI. To learn more, visit crescointernational.com.